1. The stars that were born too early. Tonight, before you fall asleep, look up at the stars for just a moment. They seem timeless, silent, patient, as though they have always been there, watching generation after generation pass beneath their steady light. For thousands of years, our ancestors looked upon these same heavens. Ancient sailors trusted the stars to guide them across unknown oceans. Farmers watched them to mark the changing seasons. Philosophers wondered whether they were eternal lamps fixed upon a great celestial ceiling. Even today, standing beneath a clear night sky, it is easy to feel that the stars belong to something permanent, something unchanging. But the universe has a remarkable habit of hiding extraordinary stories behind ordinary appearances. Because among the countless stars shining tonight are a few that began their lives so early that they have been traveling through almost the entire history of the universe. They were already glowing before the Milky Way looked anything like it does today. Before our sun was born, before Earth existed, before oceans covered our planet, before the first living cell divided in Earth's ancient seas, against every instinct we have about the passage of time. Some of those ancient stars may still be quietly shining above us tonight. Their light has survived nearly everything the universe has experienced: the birth of galaxies, the deaths of countless stars, the formation of planets, the rise of life, the appearance of humanity itself. How is that possible? How can something born so close to the beginning of time still exist? To answer that question, we must travel back. Not millions of years, not billions, but almost to the very dawn of the cosmos itself. The universe began nearly 13.8 billion years ago in an event we now call the Big Bang. At first, there were no stars, no galaxies, no planets, only an expanding sea of unimaginable heat and energy. For hundreds of thousands of years, the universe remained too hot for light to travel freely. Everything was filled with glowing plasma, where particles constantly collided in a brilliant cosmic fog. If someone could somehow witness those earliest moments, they would not see stars decorating a peaceful night sky. There was no night, no sky, only an endless ocean of blinding brightness. Gradually, however, the universe expanded. Expansion allowed temperatures to fall. Eventually, atoms could finally form. Hydrogen appeared. Helium followed. Light was finally free to travel across space. The universe entered an age unlike anything that came afterward. Astronomers sometimes call it the Cosmic Dark Ages. It is one of the most mysterious chapters in cosmic history. There were still no stars, no galaxies, no glowing nebulae, only vast clouds of hydrogen drifting silently through endless darkness. Imagine a universe holding all the ingredients necessary for a magnificent symphony. Yet not a single note had been played. Gravity, however, had already begun its patient work. Tiny differences in density, almost unimaginably small, slowly became larger over millions of years. Clouds containing slightly more hydrogen gently attracted even more gas. Their gravity strengthened. They grew heavier, denser. Little by little, invisible hands seemed to gather the universe together. No sudden explosions, no dramatic rush, only the slow persistence of gravity. Eventually, some of these ancient clouds reached a critical point. Their own weight became too great. The gas collapsed inward. Temperatures climbed rapidly. Pressure increased beyond anything we can easily imagine. Then, at last, the very first stars ignited. The universe saw its first sunrise. No human eyes were there to witness it. No planets circled nearby. No life existed to admire the view. Yet those first stars changed everything forever. These earliest stars were unlike most of the stars we see today. Modern stars, including our own sun, are born from gas enriched by countless generations of older stars. Every atom of oxygen you breathe, every atom of carbon inside your body, every atom of calcium in your bones, was forged inside stars that lived and died long before the sun existed. The first stars had none of those ingredients. They were made almost entirely of hydrogen and helium, the simplest elements in nature. Astronomers call them population 3 stars. Curiously, despite being the first stars ever born, no one has ever observed one directly. According to current theories, most of them were truly enormous. Some may have contained hundreds of times the mass of our sun. Such giants burned their fuel with astonishing speed. While our sun enjoys a lifespan of roughly 10 billion years, these colossal pioneers may have survived only a few million years before ending their lives in spectacular explosions. They lived fast, they died young, but their brief existence transformed the universe forever. Inside their blazing cores, entirely new elements were created for the first time. Carbon, oxygen, silicon, iron. When those first stars exploded, they scattered these newly forged elements into surrounding space, the raw ingredients for future planets, future oceans, future living creatures were born in those ancient stellar furnaces. In a very real sense, every person alive today carries atoms first manufactured by stars that lived before galaxies had fully matured. We are, quite literally, descendants of the universe's earliest fires. Yet the story becomes even more fascinating. Not every ancient star was enormous. Astronomers now believe that alongside those gigantic pioneers, a few much smaller stars may also have formed. Unlike their massive cousins, these little stars consumed their hydrogen extraordinarily slowly. Nature rewards patience. Large stars shine brilliantly because they burn through their fuel with incredible intensity. Small stars take a different approach. They sip rather than gulp. Instead of blazing with overwhelming brightness, they glow quietly, steadily, calmly. A star containing only a fraction of the sun's mass can survive not merely billions of years, but trillions. Some red dwarf stars are expected to shine for 10 trillion years or more. That is nearly 1,000 times longer than the current age of the universe itself. Think about what that means. The universe is still too young for even one naturally formed red dwarf to have reached the end of its life. Every red dwarf ever born is still alive, including the oldest among them. If some low-mass stars truly formed during the universe's earliest chapters, they would still be shining today, quiet witnesses to nearly everything that has ever happened. Finding such ancient survivors, however, is far from easy. Imagine searching for a single grain of sand on an endless beach. Except the beach contains hundreds of billions of stars. Astronomers cannot simply ask a star how old it is. Instead, they study subtle clues hidden within its light. Every star carries a unique chemical fingerprint. By separating its light into a spectrum, scientists can determine which elements are present in its atmosphere. Stars born very early in cosmic history contain astonishingly few heavy elements. Their light reveals extraordinary simplicity, mostly hydrogen, mostly helium. Very little else. These stars are known as metal-poor stars, although astronomers use the word metal quite differently from everyday language. To them, almost every element heavier than helium counts as a metal. When a star contains very few of these heavier elements, it becomes a compelling candidate for extreme age. One remarkable example is a star cataloged as SMSSJ 0313.6-670839.3. Its name is hardly poetic, yet its story certainly is. This faint star appears to contain so few heavy elements that it likely formed only a short time after the very first stellar generations enriched the universe. It is, in effect, a living fossil, a quiet survivor from an era when galaxies themselves were still learning how to shine. Each time astronomers observe such stars, they are not merely studying distant suns. They are reading some of the oldest surviving pages in the universe's autobiography. Perhaps that is one of the most comforting ideas hidden within the night sky. We often think of ancient things as fragile. Old books crumble, old buildings slowly collapse, old forests eventually fall. Yet the universe has managed to preserve a few quiet witnesses across almost 14 billion years. They ask for nothing. They make no grand announcements. They simply continue burning with remarkable patience, one gentle fusion reaction after another. While civilizations rise and disappear, while continents drift across Earth, while galaxies slowly collide over billions of years, these ancient stars continue their silent work, steadily transforming hydrogen into light, patiently illuminating a universe that has changed almost beyond recognition since the day they were born. And perhaps, as you look toward the stars tonight, one tiny point of light among the countless others has been waiting there since nearly the beginning of everything. It has watched galaxies grow. It has seen new suns ignite. It has quietly witnessed the birth of every world humanity has ever known. Without speaking, without moving, simply shining, a gentle reminder that in a universe where almost everything changes, a few ancient lights still refuse to go out. 2. The planets hidden between the stars. Imagine standing on the surface of a planet where morning never comes. There is no sunrise waiting beyond the horizon, no warm afternoon, no golden evening, no familiar star climbing through the sky to mark the passing of another day. Above you stretches an endless canopy of darkness. Thousands of distant stars sparkle faintly overhead, but none of them grows larger. None rises, none sets. They are simply frozen points of light, scattered across an infinite black ocean. If you waited for dawn, you would wait forever. Not because the planet spins too slowly, not because thick clouds hide its sky, but because there is no sun at all, no parent star, no solar system, only a lonely world drifting silently through the vast emptiness between the stars. It sounds like something imagined for a science fiction novel, a forgotten planet abandoned by the universe itself. Yet over the past few decades, astronomers have discovered that such worlds may be astonishingly common. There could be billions of them wandering through our Milky Way alone, invisible travelers crossing unimaginable distances, worlds without mornings, planets without homes, entire landscapes hidden forever between the stars. The universe, it seems, is filled not only with places that belong somewhere, but also with places that belong nowhere at all. When we were children, we learned a wonderfully simple picture of the cosmos. At the center of every planetary system sits a star. Around that star orbit planets. Around some planets orbit moons. It is a beautifully ordered arrangement. Our own solar system appears to follow this pattern perfectly. Mercury circles the sun. Earth circles the sun. Neptune circles the sun. Everything has its place. Everything belongs. For a very long time, astronomers believed this was simply how nature worked. Gravity gathered enormous clouds of gas into newborn stars. The leftover dust slowly formed planets. The family remained together for billions of years. Stars and planets seemed inseparable. Then, little by little, the universe revealed a more complicated story. Nature rarely enjoys simple rules. Every young planetary system begins in chaos. Although we often picture planets moving peacefully around their stars, their earliest years are surprisingly violent. Newborn planets compete for space. Gigantic worlds pull on one another with tremendous gravitational forces. Countless asteroids collide, comets scatter in every direction. Entire orbits shift slowly over millions of years. Imagine a crowded ballroom where every dancer is connected by invisible ropes. Each movement influences everyone else. No step happens entirely alone. Gravity creates a similar dance among young planets. Sometimes the choreography remains stable. Sometimes it does not. A single close encounter between two giant planets can dramatically alter an entire system. One planet may be pulled inward toward its star. Another may be flung outward. If enough energy is exchanged, one unfortunate world may gain exactly what it needs to escape forever. Gravity does not ask permission. It simply reshapes the dance. In one quiet moment, a planet that once circled its sun peacefully begins an entirely different journey. It slips away from its family, crosses the outer reaches of its system, and eventually, the star that gave it birth becomes just another tiny point of light behind it. Astronomers call these extraordinary worlds rogue planets. The name sounds adventurous, almost rebellious, as though they deliberately chose freedom over belonging. But in reality, their departures are rarely intentional. They are cosmic refugees, worlds gently exiled by gravity itself. Many likely spent millions of years orbiting warm, familiar stars before losing their homes forever. Others may have experienced something even stranger. Some scientists believe a few rogue planets may have formed entirely alone. Instead of growing inside a disk around a star, enormous clouds of gas might occasionally collapse directly into planet-sized objects without ever becoming hot enough to ignite nuclear fusion. Imagine a child born without a family, wandering the galaxy from its very first day. If this idea is correct, then not every planet has ever known the warmth of a sunrise. Some entered the universe already wrapped in darkness. The first convincing evidence for these lonely worlds arrived only recently. Because rogue planets produce almost no light of their own, they are extraordinarily difficult to detect. Finding one is a little like trying to spot a single snowflake drifting across a dark ocean at midnight. Astronomers cannot simply point a telescope toward the sky and expect to see them. Instead, they often rely on one of Einstein's most beautiful predictions: gravity bends light. Whenever a massive object passes precisely in front of a distant star, its gravity briefly acts like a gigantic invisible magnifying glass. The background star suddenly appears brighter before returning to normal. This phenomenon is known as gravitational microlensing. Sometimes the object causing that brief brightening turns out not to be a star, but a wandering planet, invisible, silent, detected only because for a few precious hours or days, it gently bent the light of a much more distant sun. It is an astonishingly delicate method of discovery. A planet announces its existence not by shining, but by quietly borrowing someone else's light. Perhaps the most remarkable question is not whether rogue planets exist. It is whether they could still remain active. At first glance, the answer seems obvious. Without sunlight, surely every rogue planet must become a frozen, lifeless ball of ice. Certainly their surfaces are unimaginably cold. Temperatures may fall to hundreds of degrees below freezing. Any oceans exposed to the surface would quickly solidify beneath layers of ancient ice. Yet appearances can be deceptive. Deep beneath the frozen crust of a planet, another source of warmth may still survive. Radioactive elements hidden within the rocky interior continue decaying over billions of years. The process is slow, gentle, almost imperceptible, but together, countless tiny reactions release heat. Earth itself still possesses a warm interior for exactly this reason. Volcanoes erupt because our planet has never completely cooled. Now imagine a rogue planet somewhat larger than Earth. If it possesses a thick atmosphere, perhaps made mostly of hydrogen, that atmosphere could trap internal heat surprisingly well. Instead of escaping into space, warmth becomes imprisoned beneath enormous blankets of gas. Scientists have suggested that such worlds might maintain liquid oceans beneath their icy surfaces for billions of years. No sunlight, no blue sky, yet perhaps liquid water. This idea transforms our understanding of what it means to be habitable. For generations, astronomers searched for planets at exactly the right distance from their stars. Too close, and water boils away. Too far, and everything freezes. This comfortable region became known as the habitable zone, but rogue planets challenge that comforting simplicity. Perhaps warmth does not always come from above. Sometimes it rises quietly from below. Instead of sunlight feeding an ocean, radioactive heat gently protects it from freezing solid. Life, if it ever appeared in such hidden seas, would experience a universe unlike anything we know. There would be no seasons, no sunsets, no changing constellations, no concept of day or night. Only endless darkness surrounding warm oceans deep beneath ancient ice. Remarkably, this idea is not entirely unfamiliar. Here in our own solar system, several icy moons, including Europa and Enceladus, already hide enormous oceans beneath frozen shells. Their surfaces receive only faint sunlight, yet internal heat keeps water liquid below. If life can survive there, perhaps it can survive almost anywhere. As these lonely planets continue wandering, they slowly orbit something far greater than any individual star. Although they no longer belong to a solar system, they still belong to the Milky Way itself. Together with billions of stars, clouds of gas and dark matter, they quietly circle the galactic center. One orbit requires roughly 250 million years. A rogue planet may complete dozens of these immense galactic journeys before eventually encountering another star. Or perhaps it never will. Some may wander forever, passing silently through the enormous spaces between stellar neighborhoods without ever being captured again. Imagine traveling across an entire continent without once seeing another traveler. Then imagine continuing that journey for billions of years. The loneliness becomes almost impossible to picture. Yet, the universe seems perfectly comfortable creating such places. Perhaps there is something strangely beautiful about these forgotten worlds. We often measure importance by connection. We admire planets because they circle bright stars. We treasure moons because they accompany planets. We celebrate galaxies because they gather billions of suns together. But rogue planets remind us that existence does not require belonging. A world may lose its home and still continue. It may wander through endless darkness without a sunrise, yet quietly preserve oceans beneath its frozen surface. It may drift unseen for billions of years, still carrying mountains, still carrying valleys, still carrying stories that no telescope has yet discovered. Somewhere tonight, between the brilliant constellations you recognize, countless hidden planets are already making that silent journey. No dawn greets them. No evening says goodbye. Only the endless galaxy stretching patiently around them. As they continue drifting through the darkness, one peaceful orbit at a time. 3. The galaxies that stopped growing. Take a moment to imagine the night sky 100 billion years from now. Not tonight's sky, filled with glittering stars and bright spiral galaxies, but a much older universe, a quieter one. Most of the brilliant blue stars have already disappeared. The great clouds of gas that once gave birth to new suns have grown thin. The fireworks of creation have slowed to little more than an occasional spark. Some galaxies are still alive. Others have quietly gone to sleep. They no longer create new stars. Their brightest days are behind them. They drift through the universe like ancient cities whose streets remain intact, yet whose windows no longer glow at night. At first glance, they still look magnificent. Billions of stars continue shining. Their graceful shapes remain almost unchanged. But hidden beneath that beauty is an extraordinary silence. No stellar nurseries, no newborn suns, no young planetary systems waiting for life to begin. Only old stars, growing older together. Astronomers sometimes describe these places as dead galaxies. The name sounds dramatic, almost tragic. Yet perhaps sleeping galaxies is a gentler description, because nothing catastrophic happened to them. They simply reached the quiet chapter of an incredibly long life. And tonight, as we continue our peaceful journey through the universe, we will discover how entire galaxies slowly grow old, why some stopped making stars billions of years ago, and why the future of our own Milky Way may one day become surprisingly similar. When we picture a galaxy, we often imagine the breathtaking spiral arms of the Milky Way or Andromeda. Blue clusters of newborn stars sparkle among glowing clouds of hydrogen. Pink nebulae stretch across the darkness like delicate brushstrokes. Everything feels vibrant, full of possibility. The universe appears endlessly creative. And for many galaxies, that impression is entirely accurate. Spiral galaxies are often wonderfully productive places. Deep inside their enormous clouds of cold hydrogen gas, gravity quietly gathers material together. As the clouds collapse, they become denser, hotter. Eventually, nuclear fusion begins. Another star is born, then another, and another. This quiet cycle has continued for billions of years. Stars live, stars die. Their explosions enrich surrounding gas with heavier elements. Those elements become part of future generations of stars and planets. It is one of the universe's greatest recycling programs, an endless circle of endings becoming beginnings. But every cycle depends upon one precious ingredient: cold hydrogen gas. Without it, stars cannot be born. Imagine a great forest. As long as seeds continue falling into rich soil, young trees replace old ones. The forest remains alive. Birds continue singing. Fresh leaves appear every spring. But eventually, imagine that no new seeds remain. The oldest trees continue standing. Year after year, they grow taller, older, wiser, yet slowly, almost imperceptibly, the forest changes. Young saplings disappear. Birdsong becomes quieter. The average age of every tree increases. Nothing dramatic happens. Life simply becomes older. Galaxies experience something remarkably similar. Over billions of years, each generation of stars consumes enormous amounts of hydrogen. Some of that gas becomes permanently locked inside long-lived stars. Some is blown away by violent supernova explosions. Some is stripped away during close encounters with neighboring galaxies. Little by little, the available supply begins shrinking. Without fresh gas flowing inward, star formation gradually slows. Not overnight, not within a million years, but across billions of years. The universe is wonderfully patient. Eventually, fewer blue stars appear. Bright nebulae become increasingly rare. The galaxy begins glowing with softer colors: yellow, orange, red. These are the colors of aging stars, stars that have survived for billions of years, stars that burn slowly and peacefully. The galaxy has not died. It has simply grown old. Astronomers often classify galaxies into two broad families. The first are the lively blue galaxies. These are still actively creating stars. Young, massive stars shine with brilliant blue-white light, making the entire galaxy appear energetic and vibrant. Then, there are the red galaxies. Their reddish color does not come from dust. It comes from age. The hot blue stars have already lived their brief lives and disappeared. Only longer-lived stars remain. Looking at one of these galaxies is a little like visiting an ancient library. Everything is still there. The stories remain. The knowledge survives. But very few new books are being written. One of the greatest mysteries in modern astronomy is understanding why some galaxies stop making stars far earlier than expected. The universe offers several possible answers. Sometimes the culprit is simply exhaustion. The galaxy has gradually used up most of its cold gas. With no fuel remaining, stellar birth quietly comes to an end. Other times, the explanation is much more dramatic. At the center of nearly every large galaxy lies a supermassive black hole. Most of the time, these giants remain surprisingly quiet. but occasionally enormous amounts of gas fall inward. As the material spirals toward the black hole, it becomes unimaginably hot. Powerful jets erupt from the galaxy's core. Radiation floods surrounding space. Instead of encouraging star formation, this violent activity can heat enormous clouds of gas until they can no longer collapse into new stars. Ironically, the galaxy's own central black hole may slowly shut down the very process that once helped build the galaxy itself. The heart becomes so energetic that the galaxy eventually falls asleep. Galaxies can also lose their ability to grow through encounters with others. Inside enormous galaxy clusters, hundreds or even thousands of galaxies orbit one another. The space between them is not completely empty. It contains extremely hot, thin gas stretching across millions of light years. As a galaxy travels through this environment, that hot gas can slowly strip away its own supply of colder hydrogen. Astronomers call this process ram pressure stripping. Imagine driving through a powerful rainstorm with loose papers stacked on the roof of your car. As you accelerate, the rushing air gradually carries the papers away. Similarly, galaxies moving through dense clusters slowly lose the material needed to create future stars. Eventually, the fuel is gone. The galaxy continues traveling, but its brightest creative years have quietly ended. Perhaps one of the most beautiful examples is the giant elliptical galaxies found near the centers of galaxy clusters. Unlike graceful spirals, these enormous galaxies often resemble glowing golden spheres. Inside them live trillions of older stars. Some are among the largest galaxies in the entire observable universe. Yet despite their incredible size, very little new star formation occurs. These cosmic giants have already completed most of their work. They are less like bustling cities and more like ancient kingdoms resting after a very long history. What makes these sleeping galaxies especially fascinating is that they still possess extraordinary beauty. Human eyes naturally admire bright blue stars because they seem energetic. But older stars possess their own quiet elegance. Many glow with warm golden light. Others become brilliant red giants during the final chapters of their lives. Some quietly end as white dwarfs. Their galaxy becomes a peaceful collection of ancient suns, each carrying billions of years of history. Perhaps these are not dead galaxies at all. Perhaps they are memory galaxies, places where almost every star has lived long enough to remember countless cosmic ages. And then there is our own Milky Way. Tonight, it remains wonderfully alive. Every year, somewhere within its spiral arms, several new stars quietly ignite. Nebulae continue glowing. Gas clouds continue collapsing. Future planets continue forming. Somewhere, perhaps, new oceans are beginning to appear around distant suns. But this activity will not continue forever. Billions of years from now, the Milky Way will collide with our neighboring Andromeda galaxy. Rather than destroying one another, the two galaxies will perform one of the slowest dances in the universe. Over billions of years, their spiral arms will intertwine. New waves of star formation may briefly blossom as enormous clouds of gas collide. Then, gradually, the fireworks will fade. The merged galaxy, sometimes nicknamed Milkomeda, will likely become a giant elliptical galaxy. Much of its gas will have been consumed or heated. Star formation will slow, then slow again, until one day, even our cosmic home may join the countless sleeping galaxies scattered across the universe. There is something unexpectedly comforting about this future. We often imagine growing older as losing something valuable, but the universe suggests another perspective. A sleeping galaxy is not empty. It is not broken. It is filled with the accumulated light of countless generations of stars. Every old sun tells a story. Every white dwarf remembers a brighter past. every planet still circles quietly beneath ancient skies. The galaxy has simply exchanged youthful energy for timeless wisdom. Perhaps that is why these silent galaxies seem so peaceful. They no longer rush to create. They no longer blaze with frantic activity. They simply drift through the darkness, carrying the memories of billions of years inside every star they still hold. And somewhere tonight, beyond the reach of even our largest telescopes, countless galaxies have already entered that peaceful chapter. Their brightest days are behind them. Yet, they continue shining softly across the universe. Gentle reminders that even in the cosmos, growing old can be a beautiful thing. If these peaceful journeys through the cosmos are helping you unwind, consider subscribing so we can continue discovering the universe's quietest stories together. 4. The light that will never reach anyone. Every night, the universe performs an invisible miracle. Somewhere, a newborn star ignites for the very first time. Deep inside its brilliant core, hydrogen atoms begin fusing into helium, releasing enormous amounts of energy. A tiny particle of light, a photon, is finally born. It escapes the star's glowing surface. It rushes into the darkness at the fastest speed nature allows. Its journey has begun. Perhaps it will travel for 4 years before reaching a nearby star. Perhaps 40. Perhaps 4 million. Perhaps 4 billion. The photon has no map, no destination, no way of knowing whether anyone will ever see it. It simply moves forward, second after second, year after year, century after century. But here is the extraordinary secret. Many of those tiny travelers will never arrive anywhere. They will never warm the surface of another planet, never illuminate an alien sky, never reflect from an ocean, never enter the eye of a curious observer. Instead, they will continue crossing an ever-expanding universe forever, alone, endlessly, without ever completing the journey they began. Tonight, we often imagine light as something that connects the universe, yet much of it may spend eternity speaking to no one at all. It is surprisingly easy to forget just how enormous the universe truly is. Here on Earth, light seems wonderfully fast. Sunlight reaches our planet in just over 8 minutes. A flashlight instantly brightens a dark room. Laser beams cross enormous distances in fractions of a second. Compared to human experience, light feels almost magical, almost instantaneous. Yet, the universe quietly reminds us that even the fastest traveler has limits. Light can move no faster than about 300,000 kilometers every second. Nothing with information can outrun it. It is nature's ultimate speed limit. If the universe were only the size of our solar system, perhaps that would be enough. But the universe is vastly larger than anything our everyday intuition can comfortably imagine. The nearest star beyond our sun lies more than 4 light-years away. The Milky Way stretches roughly 100,000 light-years across. The Andromeda Galaxy waits over 2 million light-years from Earth. The observable universe extends for tens of billions of light-years in every direction. Even light requires extraordinary patience. Earlier tonight, we followed ancient beams of starlight that successfully reached Earth after journeys lasting millions or even billions of years. Those remarkable travelers completed their incredible voyage, but they represent only a tiny fraction of all the light ever produced. Every star shines in every direction, not only toward Earth. Imagine placing a candle in the center of a dark room. Its light spreads outward equally. Only a tiny portion reaches your eyes. Most of the light strikes empty walls or disappears into the darkness beyond. Stars behave in exactly the same way. Our sun releases around 10 quadrillion trillion photons every second. The number is so enormous that language begins to lose its usefulness. Yet only an unimaginably small fraction of those photons ever reach Earth. Even fewer strike a living creature. Most continue outward into the emptiness beyond the solar system. passing the orbit of Neptune, crossing the distant Oort cloud, leaving the sun's gravitational influence behind. Then, nothing. Only darkness. Only distance. Only time. Some of those photons may eventually encounter another star system, perhaps millions of years from now. A few may gently warm the surface of a distant planet. Some may become part of an unfamiliar ocean. Others could nourish alien plants, if such things exist. One or two might eventually enter the eyes of beings looking toward our sun from unimaginably far away. But statistically, most never will. Space is simply too empty. The average distance between stars is astonishingly large. Even inside a galaxy crowded with hundreds of billions of stars, almost all of space remains completely vacant. A photon leaving the sun has an overwhelming chance of meeting absolutely nothing. Imagine releasing a single grain of sand into an ocean larger than all Earth's seas combined. The likelihood of it landing on one specific shell resting at the bottom becomes almost impossible to imagine. That is how empty the universe truly is. Yet, there is another reason many photons never find a destination. The universe itself is changing. When Edwin Hubble studied distant galaxies nearly a century ago, he made one of astronomy's greatest discoveries. The universe is expanding. Galaxies are slowly moving farther apart, not because they are racing through space like ships across an ocean, but because space itself is stretching. Imagine tiny dots drawn on the surface of a balloon. As the balloon inflates, every dot moves farther from every other dot. None of the dots are traveling across the rubber. Instead, the rubber itself expands. Our universe behaves in a remarkably similar way. Every billion years, distant galaxies become a little farther away. The space between them quietly grows. This gentle expansion creates one of the most beautiful and saddest stories in cosmology. Suppose a photon begins traveling toward a galaxy billions of light years away. It faithfully races across space at the speed of light. Yet, while it travels, the destination continues moving farther away, not because the galaxy is escaping through space, because new space continually appears between them. It resembles trying to walk toward the horizon while the landscape itself slowly stretches beneath your feet. Sometimes, the stretching wins. For galaxies beyond a certain distance, expansion carries them away so effectively that light emitted today will never catch them, no matter how patiently those photons travel. The destination retreats forever. The journey has no ending. Astronomers refer to this invisible boundary as the cosmic event horizon. It is one of the strangest ideas in modern physics. Beyond this horizon, events occurring today can never influence us. Likewise, light leaving our galaxy today can never reach those unimaginably distant regions, not because it is too slow, but because the universe itself expands too quickly on those enormous scales. The photon continues moving. It never stops, yet it never arrives. Imagine writing a beautiful letter, sealing it carefully, sending it across an ocean, only to discover that the shoreline itself moves away faster than the ship can sail. The message exists, the journey continues. But the conversation never happens. As billions of years pass, this quiet isolation becomes even more profound. Galaxies beyond our local group gradually disappear from view. Not because their stars go dark. Their light simply becomes stretched by cosmic expansion. Its wavelength grows longer and longer. Visible light slowly becomes infrared, then microwave radiation. Eventually, radio waves longer than entire cities. Their energy weakens. Their message fades. One day, unimaginably far in the future, observers inside our galaxy may no longer see evidence that other galaxies ever existed. Their skies could appear strangely empty. The universe would seem far smaller than it truly is. all because ancient light could no longer complete its journey. Yet perhaps there is another way to think about these lonely photons. We often measure success by arrival, by reaching a destination, by completing a journey. Nature does not always share that perspective. A photon never becomes tired. It never grows impatient. It never wonders whether the trip is worthwhile. It simply continues, second after second, across distances so enormous that human history becomes almost invisible. Perhaps somewhere beyond our imagination, one lonely photon released by our sun during the age of dinosaurs is still traveling. It has crossed interstellar clouds, past silent rogue planets, moved through vast cosmic voids where millions of light years contain almost nothing at all. It continues exactly as it always has, faithfully, quietly, without ever knowing whether anyone waits ahead. There is something deeply moving about that image. The universe is often described as a place of spectacular explosions, violent collisions, and unimaginable energies. Yet hidden beneath all that grandeur are countless tiny journeys unfolding in complete silence. Every second, stars produce oceans of light. Most of those photons begin adventures that will never be celebrated. They leave home, they cross the darkness, they continue onward without applause, without witnesses, without endings, and perhaps that is why the night sky feels so peaceful. Every star we see is not merely shining, it is endlessly telling stories. Some reach us, most never will. But all of them become part of the quiet conversation the universe has been having with itself since the very first stars were born. Some conversations find listeners. Others drift forever through the darkness, still beautiful, still moving, still carrying their silent message, one beam of light at a time. 5. The mountains, taller than entire planets. When you think of the tallest mountain in the world, one name almost certainly comes to mind: Mount Everest. Its snow-covered summit rises nearly 9 kilometers above sea level. For centuries, it has inspired explorers, challenged climbers, and reminded us how small we are compared to the landscapes of our own planet. Standing on its summit feels like standing at the roof of Earth. Above you, there is only sky. It seems almost impossible to imagine anything larger. But the universe has never been interested in our definitions of big. Somewhere beyond our familiar world are mountains so immense that Everest would disappear against their slopes. Mountains so tall they would extend far beyond Earth's atmosphere. Mountains so enormous that, if placed upon our planet, their peaks would rise into the darkness of space itself. And perhaps the most astonishing part of all? Many of them did not form through slow geological processes like those on Earth. Some were sculpted by ancient volcanoes. Others were built by unimaginable collisions. A few exist only because gravity behaves differently on worlds far stranger than our own. Tonight, we leave behind the gentle valleys of Earth and begin climbing the tallest landscapes the universe has ever created. Mountains are among nature's greatest storytellers. Every cliff, every ridge, every layer of exposed rock preserves a chapter from the history of the world beneath it. On Earth, mountains usually grow because enormous pieces of the planet's crust slowly push against one another. The movement is almost unbelievably slow. Our fingernails grow faster than most mountain ranges rise, yet, given millions of years, tiny motions become colossal landscapes. The Himalayas continue growing even today. Each year, India presses a little farther into Asia. The rocks respond by slowly folding upward. Time becomes architecture. Patience becomes stone. But this familiar process depends upon something Earth possesses that many other worlds do not: moving tectonic plates. Without plate tectonics, mountains must find other ways to exist. Fortunately, the universe is wonderfully creative. One of the first surprises waits next door. Mars appears quiet today. Its deserts stretch endlessly, beneath a pale salmon-colored sky. Dust storms sometimes engulf the entire planet. No rivers carve new valleys. No continents drift. No forests cover its surface. At first glance, Mars seems almost frozen in time. Yet towering above those silent plains stands the largest volcano ever discovered. Its name is Olympus Mons. Calling it a mountain almost feels inadequate. Olympus Mons rises about 22 kilometers above the surrounding plains. That is nearly 3 times the height of Mount Everest measured from sea level. Its base stretches roughly 600 kilometers across, so vast that if you stood upon its gentle slopes, you might not even realize you were climbing. The curve of the mountain blends so gradually into the horizon that it feels more like standing on an enormous continent than approaching a peak. Why could Mars create something so gigantic while Earth never did? The answer lies beneath the ground. Unlike Earth, Mars has no active plate tectonics. Here on Earth, volcanic hotspots slowly move beneath shifting crustal plates. A volcano forms. Then the plate carries it away. A new volcano begins elsewhere. This constant movement prevents any single volcano from growing forever. Mars never had that advantage. Its crust remained largely fixed above powerful volcanic hotspots for extraordinarily long periods. Lava continued erupting from the same location again and again. Layer upon layer accumulated, century after century, million year after million year. Eventually, the tallest volcano in the solar system was born, not through violence alone, but through astonishing persistence. Olympus Mons also benefited from another remarkable gift. Mars possesses only about 38% of Earth's gravity. Lower gravity means heavy mountains place less stress upon the crust supporting them. Imagine stacking books on a sturdy table. On Earth, eventually the weight becomes too great. The table begins bending. Now imagine performing the same experiment on a world where every book weighs only a third as much. The table can support a much taller stack before collapsing. Planetary crust behaves similarly. Mars allows mountains to grow far larger before gravity begins pulling them back down. Nature quietly adjusts its architecture according to the strength of each world's gravity. Yet Olympus Mons is not the only giant. Its neighboring volcanoes, Ascraeus Mons, Arsia Mons, and Pavonis Mons, also rise to astonishing heights. Together they form the Tharsis region, one of the greatest volcanic provinces in the solar system. Seen from orbit, the landscape resembles an entire continent lifted high above the surrounding plains. If Earth possessed a volcanic complex of similar size, it would dominate nearly everything we know about geography. But not every cosmic mountain forms through fire. Some emerge through unimaginable impacts. Travel to the asteroid Vesta, one of the largest objects in the asteroid belt, and you encounter a mountain unlike anything on Earth. Near its south pole rises an enormous central peak created by an ancient collision. Scientists estimate this mountain reaches around 22 kilometers high. Remarkably, Vesta itself measures only about 500 kilometers across. Imagine placing a mountain nearly as tall as Olympus Mons onto a body dramatically smaller than our moon. It is almost as though one enormous impact reshaped nearly the entire asteroid. The mountain exists because the collision was so powerful that the surface rebounded upward after being compressed, much like a drop of water splashing upward after a stone strikes a pond. Even destruction, it seems, can become a sculptor. Some of the strangest mountains may not even be made entirely of rock. On Pluto, the New Horizons spacecraft revealed towering ranges composed largely of frozen water ice. At the unimaginably cold temperatures found there, ordinary water becomes as hard as granite. Materials that seem soft and familiar on Earth transform into the structural foundations of mountains. Meanwhile, nitrogen and methane behave almost like glaciers, slowly flowing across the landscape. Imagine climbing a mountain made not of stone, but of frozen water stronger than concrete. Beneath your feet, rivers of solid nitrogen creep almost imperceptibly through valleys carved over millions of years. The laws of geology have not changed. Only the ingredients have. Even Saturn's tiny moon, Iapetus, possesses one of the solar system's greatest geological mysteries. Running almost perfectly around its equator is a colossal ridge reaching up to 20 kilometers high in places. It looks less like an ordinary mountain chain and more like a giant seam stitched across the moon's surface. To this day, scientists continue debating exactly how it formed. Perhaps material from an ancient ring system slowly collapsed onto the equator. Perhaps internal geological forces pushed the crust upward. No one knows for certain. The universe still keeps many of its architectural secrets. Then there are mountains that challenge our very definition of the word. On some neutron stars, the strongest material in the known universe forms tiny irregularities on the surface. Because gravity there is unimaginably intense, hundreds of billions of times stronger than Earth's. Even a mountain only a few centimeters high may represent the greatest structural stress matter can survive. If somehow transported to Earth, the material supporting those microscopic mountains would outweigh entire mountain ranges. Size, it turns out, is not always measured in height. Sometimes it is measured in the extraordinary forces required simply to exist. But as astronomers continue discovering planets around distant stars, they increasingly suspect that landscapes beyond our solar system may surpass anything we have yet imagined. Some rocky super-Earths possess much stronger gravity than our own world. Mountains there may struggle to rise before collapsing under their own weight. Elsewhere, lighter planets could support towering cliffs reaching incredible heights. On icy exoplanets, mountains may consist of frozen ammonia or methane. On lava worlds orbiting close to their stars, entire mountain ranges might glow red beneath rivers of molten rock. Nature appears endlessly inventive. Given enough time, enough gravity, and enough imagination, the universe finds another way to build. Perhaps the most beautiful lesson hidden within these enormous mountains has little to do with their size. Whether built by slow volcanic eruptions, ancient impacts, frozen oceans, or forces we barely understand, each one tells the story of patience. None appeared overnight. Each required millions or even billions of years to become what it is today. The universe rarely hurries. It creates greatness grain by grain, layer by layer, eruption after eruption, collision after collision. Until one day, something astonishing quietly stands where once there was almost nothing. And somewhere tonight, beneath skies no human has ever seen, mountains taller than entire planets continue waiting in silence, their summits untouched, their valleys unexplored, their stories unread, patiently rising beneath alien skies. One quiet age at a time. 6. The oceans that have never seen the sky. Imagine standing beside an ocean that has existed for billions of years. Its waters are calm, ancient, perhaps older than every mountain on Earth, older than the dinosaurs, older than the moon's familiar face as we know it today. Yet no sunlight has ever shimmered across its surface. No waves have reflected a sunrise. No clouds have drifted overhead. No bird has ever flown above its waters. No wind has ever disturbed a single ripple. Because this ocean has never seen the sky, it lies buried beneath miles of solid ice, hidden inside a frozen world where daylight is little more than a distant memory. For countless ages, it has remained completely isolated from the rest of the universe, an entire sea, waiting silently in the darkness. At first, that sounds impossible. Water freezes, everyone knows that. Move far enough away from the warmth of the sun, and every ocean should become solid ice. Entire worlds should freeze into lifeless spheres. End of story. But the universe rarely chooses the simplest ending. Sometimes the greatest oceans are the ones no telescope can see, hidden beneath frozen shells that have protected them since the earliest chapters of the solar system. And perhaps, somewhere beneath those silent waters, life has been waiting all along. When most people imagine an ocean, they picture Earth. Blue waves stretching toward the horizon, sunlight dancing across the surface, tides rising beneath the moon, whales singing through deep water. Every ocean we have ever known exists beneath an open sky. Water and sunlight seem inseparable. It is difficult to imagine one without the other. Yet our own solar system quietly challenges that assumption. Some of its most fascinating oceans are not found on planets at all. They are hidden inside icy moons orbiting giant worlds, invisible from above, protected beneath thick shells of ancient ice. These are known as subsurface oceans, and they may contain more liquid water than every ocean on Earth combined. Perhaps the most famous of these hidden worlds is Europa, one of Jupiter's largest moons. From a distance, Europa appears smooth and peaceful. Its bright icy surface reflects sunlight like polished marble. Long reddish cracks stretch across the landscape, giving it the appearance of a giant frozen puzzle. For centuries, that icy shell was all anyone could see. It looked cold, still, silent, but appearances can be wonderfully misleading. Beneath that frozen crust, thought to be between 15 and 25 kilometers thick, scientists believe an enormous global ocean quietly exists. Not a lake, not scattered pools, an entire planet-wide ocean. Some estimates suggest Europa may contain twice as much liquid water as all of Earth's oceans combined. Imagine that, a world smaller than our moon, yet hiding enough water to completely reshape our understanding of where life might exist. The obvious question is simple: how? Europa is incredibly far from the Sun. At Jupiter's distance, sunlight is already 25 times weaker than it is on Earth. Surface temperatures plunge to around -160 degrees Celsius. Under those conditions, everything should remain frozen forever. The answer comes not from above, but from below. Europa experiences an extraordinary process called tidal heating. As Europa travels around Jupiter, the giant planet's immense gravity constantly squeezes and stretches the little moon. Its orbit is not perfectly circular. Sometimes Europa moves slightly closer to Jupiter, sometimes slightly farther away. Each orbit gently flexes the moon's interior. Imagine bending a paperclip back and forth. After enough movement, the metal becomes warm. Europa experiences something remarkably similar. Except, instead of metal, an entire moon slowly flexes under gravity. That continuous stretching generates heat deep inside, enough heat to keep its hidden ocean from freezing solid. Gravity itself becomes an invisible fireplace. If someone could somehow drill through Europa's icy shell, the journey would be extraordinary. At first, only frozen water, kilometer after kilometer of ancient ice. The deeper you travel, the greater the pressure becomes. Then, suddenly, the drill breaks through. Below lies an ocean unlike anything humanity has ever seen. Absolute darkness. No sunlight has reached these waters for billions of years. No sunrise has ever begun there, yet the ocean may still be astonishingly active. Powerful currents slowly circulate beneath the ice. Minerals dissolve into the water. Perhaps hydrothermal vents rise from the rocky seafloor below. Remarkably, this hidden world may resemble parts of Earth's own deep oceans, far more than its frozen surface suggests. Our own planet offers a fascinating clue. Deep beneath Earth's oceans, far beyond the reach of sunlight, hydrothermal vents release superheated mineral-rich water into the surrounding sea. When scientists first discovered these vents in the late 20th century, they expected to find little or no life. After all, without sunlight, how could ecosystems survive? Instead, they found thriving communities. Towering tube worms, blind shrimp, strange bacteria, entire ecosystems powered not by sunlight, but by chemistry. Instead of photosynthesis, tiny organisms use chemical energy released by Earth's interior. This process is called chemosynthesis. Life, it turns out, does not always need the sun. It only needs energy. That realization changed everything. If life can flourish around Earth's hydrothermal vents, could something similar exist beneath Europa's frozen shell? No one knows. But for the first time in history, the question no longer sounds impossible. Europa is not alone. Farther from the sun, another icy moon quietly guards an even more spectacular secret. Enceladus, one of Saturn's smaller moons, is only about 500 kilometers across. At first glance, it seems far too small to remain geologically active. Yet in 2005, NASA's Cassini spacecraft witnessed something astonishing. Towering geysers erupted from enormous fractures near Enceladus's south pole. Jets of water vapor, ice crystals, and organic molecules blasted hundreds of kilometers into space. The discovery stunned scientists. Some of that material escaped entirely, becoming part of Saturn's magnificent E ring. Even more remarkable, Cassini actually flew through these icy plumes. Its instruments detected water, salts, complex carbon-containing molecules, and even tiny particles that likely formed around hydrothermal vents on the ocean floor. Without drilling a single hole, humanity had effectively sampled an alien ocean. The sea remained hidden, yet it had quietly sent pieces of itself into space, almost as though it wished to introduce itself. Then there is Titan, Saturn's largest moon. Unlike Europa and Enceladus, Titan possesses a thick atmosphere and rivers flowing across its surface. But these rivers are not made of water. They consist of liquid methane and ethane. The temperatures are far too cold for ordinary water to remain liquid. Instead, water forms bedrock as solid as granite. Yet beneath Titan's icy crust, scientists believe another enormous ocean quietly exists. Layer upon layer of ice seals it away from the surface. Above lies a strange world filled with methane rain, orange skies, and hydrocarbon lakes. Below, perhaps another hidden sea. One world. Two completely different oceans, separated forever by frozen stone. As astronomers searched farther into the solar system, they realized hidden oceans might be surprisingly common. Even distant dwarf planets may have once contained underground seas. Some may still. Radioactive elements buried deep within rocky interiors slowly release heat over billions of years. Combined with thick insulating layers of ice, that warmth can preserve liquid water far longer than anyone once imagined. The traditional idea of a habitable zone, where liquid water exists only at the right distance from a star, began to feel incomplete. Perhaps life does not always need a comfortable orbit around a bright sun. Perhaps entire ecosystems can survive inside frozen worlds, drifting through darkness. The universe suddenly became filled with many more possibilities. Imagine living within one of those hidden oceans. There is no concept of day. No sunrise announces the morning. No sunset signals evening. Time is measured only by gentle currents, distant vibrations, or the slow movement of warm water rising from the depths. Above you rests a ceiling of ice, perhaps 20 kilometers thick. No one has ever broken through it. No ray of sunlight has ever pierced its frozen barrier. The stars are unknown. Galaxies do not exist. The universe, as far as any living creature there might understand, consists only of endless water stretching into darkness. Would such beings even imagine a sky? Could they conceive of sunlight? Or would they believe the ocean itself is the entire universe? It is a strangely humbling thought. Perhaps somewhere beneath that ancient ice, curiosity exists. Questions exist. Wonder exists. Without ever knowing there is an entire cosmos waiting beyond the frozen ceiling. There is something profoundly peaceful about these hidden seas. Unlike Earth's oceans, they know no storms. No hurricanes churn their surfaces. No crashing waves strike rocky cliffs. No winds disturb their stillness. For billions of years, they have rested beneath their icy blankets, quietly preserving some of the oldest water in our cosmic neighborhood. Patient, silent, untouched. And somewhere, deep beneath miles of frozen ice, entire oceans continue waiting in perfect darkness. They have never watched a sunrise. They have never reflected the stars. Yet, they may still carry the greatest mystery of all. The possibility that life learned to flourish without ever seeing the sky. 7. The stars waiting for the end of time. Look up at the night sky tonight. Every star you see seems permanent, steady, unchanging, as though it has always been there and always will be. But if the universe could speak, it might gently remind us that every star has its own lifetime. Some burn brightly for only a few million years. Others survive for billions. And a remarkable few have barely begun living at all. Long after our sun has faded into darkness. Long after the Milky Way has changed beyond recognition. Long after nearly every familiar constellation has disappeared from the skies. These quiet little stars may still be shining, patiently waiting for a future so distant that human language struggles to describe it. They are not the largest stars, nor the brightest. Few people notice them when they gaze into the heavens, yet they may become the final guardians of starlight itself, the last tiny lanterns glowing in an aging universe. Tonight, we have already wandered among ancient galaxies, hidden oceans, lonely planets, and forgotten beams of light. Now our journey carries us even farther into the future, toward stars that seem almost unwilling to grow old, stars that may continue shining until the universe itself begins forgetting what daylight once looked like. It is natural to assume that larger things last longer. A great oak tree survives longer than a flower. A mountain outlives a forest. An ocean outlasts a river. Our everyday experience teaches us that size often brings endurance. The universe quietly disagrees. Among stars, the opposite is true. The biggest stars live the shortest lives. Imagine placing two candles on a table. One has an enormous flame, burning brilliantly. The other glows softly with only a tiny flicker. Which candle lasts longer? Almost certainly the smaller one. The great flame consumes its wax rapidly. The smaller flame burns patiently. Stars behave in much the same way. Massive stars blaze with astonishing intensity. Their tremendous gravity compresses their cores to extraordinary temperatures. Hydrogen fuses rapidly. Energy pours into space. These stellar giants can shine millions of times brighter than our sun. But brilliance comes at a price. They exhaust their fuel surprisingly quickly. Some survive only a few million years before ending their lives in spectacular supernova explosions. On cosmic timescales, they are little more than dazzling fireworks. Beautiful, powerful, brief. Our own sun lives somewhere in the middle. Compared with truly massive stars, it is remarkably patient. It has already shone for about 4.5 billion years. Scientists expect it to continue burning peacefully for roughly another 5 billion. 10 billion years sounds unimaginably long. Long enough for continents to rearrange themselves countless times. Long enough for entirely new branches of life to evolve. Long enough for civilizations to appear and disappear beyond counting. Yet even the sun's lifetime is only a short chapter compared with the quiet stars waiting beyond it. These extraordinary objects are known as red dwarfs. At first glance, they seem almost unimpressive. They are small, cool, dim. Many shine with less than 1% of the sun's brightness. Some are so faint that they cannot be seen with the naked eye despite being among our nearest stellar neighbors. If our sun were replaced by one of them, daylight on Earth would almost disappear. The sky would resemble an endless twilight. Yet hidden behind their modest appearance lies one of nature's greatest secrets. Red dwarfs are astonishingly efficient. Unlike larger stars, they do not waste their fuel. Inside the sun, hydrogen fusion occurs only within the central core. Most of the surrounding hydrogen never participates directly in that process. Eventually, the core runs out of usable fuel, even though much hydrogen still remains elsewhere inside the star. Red dwarfs work differently. Because they are much smaller, hot material rises while cooler material sinks throughout almost the entire star. Astronomers call this convection. Imagine gently stirring a pot of soup. Instead of remaining separated into layers, everything slowly mixes together. Red dwarfs perform this quiet stirring naturally. Fresh hydrogen continually reaches the center. Old material drifts outward. Almost the entire star becomes available as fuel. Nothing is wasted. Nature rarely rewards impatience, but it greatly rewards efficiency. Because of this remarkable design, red dwarfs burn extraordinarily slowly. Some may survive for 1 trillion years, others perhaps 5 trillion. The smallest could continue shining for 10 trillion years or even longer. To appreciate that number, consider this. The universe itself is only about 13.8 billion years old. 10 trillion years is roughly 700 times longer. If the entire history of the universe so far were compressed into a single day, the complete lifetime of one tiny red dwarf would stretch for nearly 2 years. These stars have scarcely begun their lives. Every red dwarf that has ever naturally formed is still alive today. Not one has yet reached old age. The universe simply has not existed long enough. Perhaps the most famous example is Proxima Centauri, the nearest star to our solar system. Although invisible to the unaided eye, it quietly circles the larger Alpha Centauri system just over 4 light-years away. It is a red dwarf, tiny compared with the Sun, much cooler, much fainter. Yet long after Earth has vanished, long after our Sun has become a cold white dwarf, Proxima Centauri will almost certainly continue shining, patiently, calmly, almost unchanged. Nearby, Barnard's star, another red dwarf, has already spent billions of years quietly traveling through the Milky Way. It moves across our sky faster than almost any other known star relative to the background stars. Yet even this ancient traveler remains remarkably youthful compared with the immense future still awaiting it. One day, unimaginably far from now, the universe itself will begin changing around these quiet suns. Earlier tonight, we explored galaxies that eventually stop producing new stars. Billions of years later, almost every bright blue giant will have disappeared. White dwarfs will slowly cool. Neutron stars will quietly drift through aging galaxies. The great spiral arms that define today's Milky Way may no longer exist. Yet scattered throughout this quieter universe, countless red dwarfs will continue glowing. If any intelligent civilizations survive into those distant ages, these tiny stars may become priceless. They will represent the last dependable sources of warmth and light. Entire future worlds could spend trillions of years orbiting stars that seem almost immortal. For those distant civilizations, our present universe, with its countless bright young stars, might feel like an ancient golden age described only in forgotten histories. Eventually, however, even the most patient stars reach the end of their stories. Unlike massive stars, red dwarfs will not explode dramatically. They simply become hotter and brighter very slowly as they consume their fuel. After unimaginable ages, many are expected to transform into what astronomers call blue dwarfs, a type of star so long-lived that none yet exist anywhere in the universe. The cosmos is still far too young. Every blue dwarf belongs entirely to the future. After exhausting their hydrogen, these stars will quietly become white dwarfs. Then, over even longer spans of time, they will cool toward darkness. Their endings will be gentle, almost silent, no violent farewell. only a slow fading into the night. There is something deeply comforting about these tiny stars. Human beings often admire brilliance, the brightest performer, the loudest voice, the fastest runner, the grandest achievement. The universe quietly celebrates something else: consistency, patience, endurance. Red dwarfs never hurry. They do not compete with giant blue stars blazing across galaxies. They simply continue doing the same quiet work day after day, year after year, trillion after trillion. Sometimes the smallest light lasts the longest. Perhaps that lesson extends far beyond astronomy. We often imagine that significance comes from burning as brightly as possible. Yet nature reminds us that quiet persistence can shape the future in ways dramatic moments never could. A tiny star, almost invisible beside the sun, may ultimately outlive entire galaxies filled with brighter companions. Its greatness lies not in intensity, but in faithfulness, in simply continuing. Somewhere above us tonight, billions of red dwarfs are already beginning these astonishingly long lives. They do not know they are destined to witness the final chapters of the stellar universe. They simply shine, patiently converting hydrogen into light, illuminating planets that may never be discovered, watching galaxies slowly grow old around them, waiting peacefully for an ending so distant that even time itself seems almost young. Perhaps one of those quiet little stars will still be glowing when every constellation we recognize has vanished forever, when the last familiar sunsets have become ancient memories, when the universe grows quieter than we can possibly imagine, still shining, still waiting, one gentle heartbeat of light at a time. If you're enjoying these gentle explorations across space and time, subscribing helps us continue sharing one peaceful cosmic mystery at a time. 8. The places where gravity falls asleep. There are places in the universe where silence has become almost infinite. No brilliant spiral galaxies decorate the horizon. No glowing nebulae drift across the darkness. No clusters of stars gather together in dazzling clouds. If you could somehow stand there, far beyond any known galaxy, you might wait millions of years before seeing another island of light. The universe would seem abandoned, almost empty. It would feel as though gravity itself had simply fallen asleep. For most of our lives, gravity has been the invisible architect of everything we know. It gathers gas into stars. It binds planets to their suns. It shapes galaxies. It keeps moons in orbit. It slowly pulls entire galaxy clusters toward one another across unimaginable distances. Gravity seems impossible to escape. And yet, there are regions so astonishingly empty that gravity barely has anything left to hold. Galaxies drift through these immense expanses almost completely alone, separated by tens of millions of light-years of darkness. These places are called cosmic voids, and together they make up most of the universe. Tonight, we journey into the quietest landscapes that exist anywhere in creation. Places where emptiness itself becomes the main feature, where distance loses its meaning, and where the silence between galaxies may tell us just as much about the universe as the galaxies themselves. When we look at photographs of the night sky, it is easy to imagine that the universe is crowded. Stars seem packed tightly together. Galaxies appear in dazzling clusters. Every direction looks full of light. But this impression is wonderfully misleading. Imagine shrinking every galaxy into the size of a grain of sand. Now scatter those grains across an entire continent. Most of the continent would remain completely empty. The grains would gather into occasional clusters. Between them would stretch enormous regions containing almost nothing at all. That is remarkably similar to the large-scale structure of our universe. Galaxies are not spread evenly through space. Instead, they gather into an immense cosmic web. Long filaments of galaxies stretch across hundreds of millions of light-years, connecting gigantic clusters like delicate strands of silk. Between these filaments lie enormous bubbles of emptiness, the cosmic voids. If the galaxies are cities, the voids are oceans larger than imagination itself. This magnificent structure did not appear overnight. In the earliest moments after the Big Bang, matter was distributed surprisingly evenly throughout the young universe. Not perfectly. Tiny fluctuations existed. Some regions contained just a little more matter than others. The differences were astonishingly small, less than 1 part in 100,000. Yet gravity is remarkably patient. Over billions of years, slightly denser regions slowly attracted more material. As they became heavier, their gravity strengthened. They pulled in even more matter. Little by little, galaxies began forming where matter accumulated. Meanwhile, neighboring regions slowly lost material. Gravity gently drained them. Like rainwater flowing into rivers, matter gradually migrated toward denser regions, leaving behind larger and larger empty spaces. The rich became richer. The empty became emptier. Eventually, enormous voids emerged between the growing filaments of galaxies. The universe quietly organized itself into a breathtaking network of light surrounding oceans of darkness. Some of these voids are almost unimaginably large. One remarkable example is the Boötes void. Discovered in 1981, it stretches roughly 330 million light-years across. To appreciate that scale, remember that our entire Milky Way is about 100,000 light-years wide. You could line up more than 3,000 Milky Ways side by side before reaching the opposite edge of this single empty region. Inside such a volume, astronomers expected to find thousands of galaxies. Instead, only a few dozen have been discovered. Imagine walking through an enormous city where almost every building has vanished. The streets remain. The space exists, but nearly everyone has quietly disappeared. That is the feeling these cosmic voids evoke. Not complete emptiness, but astonishing loneliness. Suppose you lived inside one of these vast voids. Your night sky would look profoundly different. Nearby galaxies would be incredibly scarce. Many of the brilliant structures familiar to astronomers would simply not exist. The universe would appear much smaller than it truly is. For generations, your civilization might reasonably conclude that galaxies are extraordinarily rare. Only after building increasingly powerful telescopes would they slowly discover distant walls of galaxies surrounding them far beyond the darkness. They would realize they had grown up inside one of the quietest neighborhoods in existence. Our own Milky Way is fortunate. We reside near the edge of a relatively modest region called the local void, but we are also connected to neighboring galaxies through the cosmic web. Had our galaxy formed much deeper inside a giant void, astronomy itself might have developed very differently. Perhaps humanity would have waited thousands of extra years before realizing the true richness of the cosmos. What is it actually like inside a cosmic void? Contrary to the name, it is not completely empty. A few lonely galaxies continue drifting there. Small clouds of gas remain. Dark matter still quietly passes through. Even individual atoms occasionally wander across these enormous distances. But compared with the crowded galaxy clusters elsewhere, the density becomes astonishingly low. Imagine standing alone in the middle of Earth's largest desert. Now remove the sand, remove the rocks, remove the air, stretch the desert until it becomes millions of light-years wide. Only then do we begin approaching the extraordinary emptiness of a cosmic void. If a spacecraft somehow crossed one, the journey would be unlike anything humanity has ever experienced. For millions of years, almost nothing would change. No nearby stars would brighten. No neighboring galaxies would slowly grow larger. The darkness would remain almost perfectly constant. Space itself would become the landscape. Curiously, gravity behaves differently in these lonely regions. Gravity never truly disappears. Every particle still attracts every other particle. Yet, because there is so little matter present, the overall gravitational pull becomes remarkably weak. Instead of drawing galaxies inward, surrounding massive filaments often pull matter away from the void. It is almost as though the void expands simply because everything around it grows stronger. Imagine standing in the center of a gently stretching rubber sheet. People around the edges slowly walk away from you in every direction. You would not feel yourself moving very much. Instead, the empty space around you would quietly become larger. Cosmic voids evolve in a similar way. They slowly grow as galaxies continue migrating toward richer regions of the universe. In that sense, gravity has not truly fallen asleep. It has simply become distant, soft, almost whisper-like. Astronomers treasure these quiet places for an unexpected reason. Because voids contain relatively little matter, they become ideal laboratories for studying the fundamental nature of the universe. Inside crowded galaxy clusters, countless gravitational interactions complicate every observation. Inside voids, those distractions largely disappear. It is rather like trying to hear a single bird singing. In the middle of a busy city, the sound becomes difficult to isolate. Deep within a silent forest, every note becomes beautifully clear. Similarly, cosmic voids allow astronomers to test theories about dark matter, dark energy, and the large-scale evolution of the universe with remarkable precision. Sometimes, the quietest places reveal the loudest truths. There is another fascinating possibility. As the universe continues expanding, cosmic voids will become even larger. Galaxies will drift farther apart. The great filaments connecting today's galaxy clusters will slowly thin. Trillions of years from now, observers living inside surviving galaxies may find themselves increasingly isolated. The nearby universe will appear emptier than it does today. Many distant galaxies will have disappeared beyond the cosmic horizon entirely. Future astronomers may never know the universe was once filled with such magnificent structures. Their skies could resemble a vast cosmic void, not because galaxies ceased to exist, but because distance quietly carried them beyond reach. The universe grows lonelier with age. Yet perhaps these immense empty regions are not merely absences. Perhaps they are essential parts of the universe's design. Music depends not only upon notes, but also upon silence. Paintings rely not only upon color, but also upon empty space. Without pauses, melodies lose their beauty. Without darkness, stars cannot shine. The cosmic web exists because the voids exist beside it. Each gives meaning to the other. The brightest galaxy cluster appears even more magnificent when surrounded by hundreds of millions of light-years of quiet emptiness. Perhaps that is why these enormous voids feel strangely peaceful rather than frightening. They remind us that the universe does not rush to fill every corner with activity. Sometimes it chooses stillness. Sometimes it chooses silence. And somewhere tonight, beyond every familiar constellation, immense oceans of darkness continue stretching across the cosmos. Galaxies drift gently around their distant edges. Gravity whispers instead of shouts, and the universe rests in one of its quietest dreams. One empty light-year at a time. 9. The cosmic ghosts that still haunt the universe. Some things in the universe never truly disappear. A star explodes, a galaxy collides, a black hole awakens. The original event ends, the objects themselves are gone. And yet, billions of years later, faint traces of those ancient moments are still drifting through the cosmos. Invisible waves continue spreading across space. Ghostly shells of gas keep expanding long after the star that created them has vanished. Ancient light still races toward destinations it has not yet reached. Even the atoms inside your body carry memories of suns that died before Earth existed. The universe, it seems, has an astonishing memory. Nothing simply vanishes. Every great event leaves behind an echo, a fingerprint, a whisper that continues traveling through space and time long after the original voice has fallen silent. Tonight, we follow those whispers, not to haunted houses or forgotten ruins, but to the oldest ghosts in existence. Ghosts made not of spirits, but of light, gravity, radiation, and memory itself. Because somewhere above your head, hidden among the stars, the past is still quietly alive. When we hear the word ghost, we often imagine something invisible lingering after its physical form has disappeared. Surprisingly, astronomy contains many objects that behave in exactly this way. Not supernatural beings, but cosmic remnants. Evidence that something extraordinary happened long ago. Imagine walking through an ancient forest. The trees standing today tell only part of the story. Scattered beneath your feet lie old stumps, fallen trunks, and weathered rings of wood that reveal forests from centuries past. The living landscape carries memories of everything that came before. The universe works in much the same way. Every explosion, every collision, every dying star leaves behind clues that survive astonishingly long after the original event. Astronomers have become detectives, reading these quiet traces to reconstruct stories billions of years old. One of the most beautiful examples begins with a star much larger than our Sun. For millions of years, it burns brilliantly. Its core steadily transforms hydrogen into helium, then helium into heavier elements: carbon, oxygen, silicon, eventually iron. At that moment, something remarkable happens. Unlike earlier fusion reactions, iron cannot release energy by combining into heavier elements. The star's internal furnace suddenly loses its ability to support the enormous weight pressing inward. Gravity, which had patiently waited for millions of years, finally takes control. The core collapses in less than a second. Then comes one of the most powerful explosions in the universe, a supernova. For a brief time, one dying star may outshine an entire galaxy. Its outer layers race outward at millions of kilometers per hour. The original star is gone, destroyed forever. Yet, its ghost remains. Those expanding clouds of glowing gas continue drifting through space for tens of thousands of years. Astronomers call them supernova remnants. The Crab Nebula is perhaps the most famous. The explosion that created it was witnessed by Chinese astronomers in the year 1054. For weeks, the dying star appeared bright enough to see during daylight. Today, nearly 1,000 years later, the explosion itself has long since ended, but the nebula continues expanding. Filaments of glowing gas stretch across space like delicate threads woven into the darkness. At its center spins a tiny neutron star, the collapsed heart of the original Sun. The star that once existed is gone. Its ghost continues glowing. Sometimes these ghosts become even stranger. When massive stars explode, they create shock waves that race outward through interstellar space. These invisible fronts compress nearby clouds of gas. Millions of years later, entirely new stars begin forming inside those compressed clouds. In a very real sense, one generation of stars gives birth to the next. The ghost of an ancient explosion quietly becomes the cradle of future suns. Our own solar system may owe its existence to such an event. Many scientists believe a nearby supernova exploded shortly before the Sun formed. Its shock wave may have compressed the cloud that eventually became our solar system. If that idea is correct, then every planet, including Earth, owes its birth to the lingering influence of a long-vanished star. The ghost did not merely survive, it became a creator. Perhaps the oldest ghost of all fills the entire universe. Nearly 14 billion years ago, the young cosmos was unimaginably hot. Matter and light were trapped together inside a glowing sea of plasma. No stars existed, no galaxies, only brilliant radiation filling every direction. As the universe expanded, temperatures slowly fell. Eventually, atoms formed. Light finally escaped. Those ancient photons have been traveling ever since. Today, astronomers detect them as the cosmic microwave background. It is often described as the afterglow of the Big Bang, but perhaps it is more poetic to think of it as the oldest ghost in existence. The original event ended billions of years ago, yet its faint whisper still surrounds us. No matter where you travel in the observable universe, this ancient light fills the sky. Every direction carries the same quiet memory of creation itself. When radio telescopes observe this faint glow, they are not simply looking into space. They are looking almost all the way back to the beginning of time. Light itself creates many cosmic ghosts. Earlier tonight, we followed photons beginning journeys that may never end. Now imagine another possibility. Suppose a civilization living 100 million light years away points an enormous telescope toward Earth. What would they see? Certainly not modern cities, not airplanes, not satellites. The light carrying those images has not yet arrived. Instead, they would witness Earth exactly as it appeared 100 million years ago. Dinosaurs would still roam ancient forests. Humanity would not yet exist. The present disappears. The past remains visible. Throughout the universe, countless versions of history continue traveling outward at the speed of light. Ancient Earth, ancient galaxies, ancient stars. Every moment leaves behind a shell of light expanding forever. The universe never completely loses its memories. They simply drift farther away. Gravity also leaves behind ghosts. In 2015, scientists made one of the greatest discoveries in modern physics. The LIGO observatory detected gravitational waves, tiny ripples in space-time itself. These waves originated from two black holes that collided more than 1 billion years ago. The collision ended long before multicellular life became common on Earth. The black holes merged. The event disappeared into history. Yet the ripples continued traveling across the universe. Eventually, after more than 1 billion years, they gently stretched and compressed Earth by less than the width of a proton. The signal lasted only a fraction of a second. But during that brief moment, humanity heard the echo of an event unimaginably ancient, not through light, not through sound, but through gravity itself. Even space remembers. There are ghosts hidden inside every atom as well. The calcium strengthening your bones, the oxygen filling your lungs, the iron carried through your blood. None of these elements existed immediately after the Big Bang. They were forged inside stars, some inside ordinary stars, others inside spectacular supernova explosions. Many of those stars disappeared billions of years before our sun formed. Yet, their atoms survived, traveling through interstellar space, becoming part of new stars, new planets, eventually, new people. Carl Sagan once said that we are made of star stuff. Perhaps an even gentler way to express that thought is this: we are built from cosmic ghosts. Every breath carries memories older than Earth itself. Even black holes leave haunting traces. Although no light escapes from within their event horizons, astronomers often discover enormous jets extending for hundreds of thousands of light years from galaxies whose central black holes were once violently active. The feeding has stopped. The brilliant quasar has faded. Yet the giant lobes of energized particles continue drifting through space long afterward. The monster has fallen asleep. Its footprints remain. Future civilizations may discover these ancient structures without ever witnessing the spectacular activity that created them. The evidence survives. The culprit is gone. Perhaps this is one of the universe's most comforting lessons. Nothing important simply disappears. Energy changes form. Stars become nebulae. Nebulae become planets. Planets become living worlds. Living creatures eventually return their atoms to the cosmos. Every ending quietly becomes the beginning of something else. the universe remembers through transformation, not by preserving everything unchanged, but by carrying every story forward in new forms. As our journey continues, the night sky begins to feel different. The stars no longer seem like isolated points of light. Each one carries a history stretching across billions of years. Each nebula remembers an explosion. Each atom remembers an ancient furnace. Each beam of light tells the story of a place that may no longer exist exactly as we see it. Perhaps the universe is not haunted because things refuse to leave. Perhaps it is haunted because nothing truly stops echoing. Every great event sends out ripples. Some become light, some become gravity, some become the very matter from which future worlds are built. And somewhere tonight, drifting silently between the galaxies, ancient ghosts continue their endless journey. Not frightening, not lonely, simply reminding us that in the universe, the past is never entirely gone. It is still traveling, still whispering, still quietly illuminating the darkness, one forgotten memory at a time. 10. The worlds that orbit dead suns. When we imagine the death of a star, we often picture a dramatic ending. A brilliant explosion, a collapsing giant, a burst of light so powerful that it briefly outshines an entire galaxy. It feels like the final chapter. The curtain falls. The story ends. But what if the story does not end with the star? What if something remains behind? Imagine a lonely planet continuing its endless journey through space. Its familiar sunrise never comes. Its sky grows permanently dark. The warm light that once illuminated its mountains and oceans has vanished forever. Yet year after year, million after million, billion after billion, the planet continues orbiting, faithfully following the same invisible path around an object that no longer resembles a living star. A silent, stellar grave. Tonight we explore one of the quietest chapters in the life of the universe. Not the birth of planets, not the blazing lives of stars, but the strange future awaiting worlds that survive after their suns have already died. Because in the universe, endings are rarely as absolute as they first appear. Sometimes the light disappears, while the journey quietly continues. For most of its life, a star and its planets exist together in remarkable harmony. Gravity binds them into a delicate family. The star provides warmth, light, energy. Planets circle endlessly in predictable rhythms. On Earth, nearly every aspect of life depends upon this relationship. The sun drives our climate, feeds our plants, shapes our seasons. Even our sense of time follows its steady motion across the sky. It is difficult to imagine a world without its star. Yet every star, no matter how stable, eventually exhausts the hydrogen fuel deep within its core. The question is not whether stars die, only how, and what happens to everything still orbiting them afterward. Fortunately for us, our own sun is a remarkably patient star. It has already lived for about 4.5 billion years and still has roughly 5 billion more before reaching old age. Eventually, however, the balance inside its core will begin to change. Hydrogen fusion slows. Gravity presses inward. The core contracts and becomes hotter. Meanwhile, the sun's outer layers expand dramatically. It enters the red giant phase. What was once an ordinary yellow star becomes an enormous glowing sphere, hundreds of times larger than it is today. From Earth, the sun would no longer appear as the familiar disk we know. It would dominate the sky, a vast crimson giant hanging over a world growing increasingly uninhabitable. Long before the sun reaches its maximum size, Earth's oceans will likely evaporate. Its atmosphere will change beyond recognition. Life, at least as we understand it, will have vanished. Whether Earth itself survives depends upon complicated interactions between the expanding sun and our planet's changing orbit. Some models suggest Earth could eventually be swallowed. Others leave open the possibility that it escapes, scorched but still intact. Either way, the world we know will be gone. After this dramatic phase comes something surprisingly gentle. The sun will shed its outer layers into space. These glowing clouds expand outward, creating what astronomers call a planetary nebula. The name is somewhat misleading. It has nothing to do with planets. Early astronomers simply thought these colorful shells resembled distant worlds through small telescopes. In reality, they are the final breaths of dying stars. Beautiful clouds of glowing gas illuminated by the hot stellar core left behind. For a few tens of thousands of years, a brief moment in cosmic history, the nebula shines like an enormous celestial flower. Then it slowly disperses into the galaxy. The spectacle ends. What remains is the heart of the original star, a white dwarf. White dwarfs are among the strangest objects in the universe. Roughly the size of Earth, but containing about half the sun's mass, they are incredibly dense. A single teaspoon of white dwarf material would weigh several tons on Earth. They no longer generate energy through nuclear fusion. Instead, they slowly release the enormous heat stored during their earlier lives. They do not truly shine. They glow, like the embers remaining after a great fire has burned itself out. At first, the white dwarf remains intensely hot. Its surface may exceed 100,000 degrees Celsius, but over billions of years, it gradually cools, dimmer, redder. Eventually, after timescales longer than the current age of the universe, it will become a cold black dwarf. None exist yet. The universe is simply too young. What then becomes of the planets? Surprisingly, many survive. When a star loses mass during its red giant phase, its gravitational pull weakens. Planets that remain intact slowly drift outward into wider orbits. Their years become longer. Their skies become darker. Yet gravity still binds them to the stellar remnant. The family changes, but it does not entirely disappear. Imagine living on such a planet. The brilliant sun that once dominated the sky has shrunk to a tiny glowing jewel. No daylight fills the heavens. No blue skies stretch overhead. Even at noon, darkness reigns. The white dwarf appears as an intensely bright star rather than a great solar disk. Its light provides little warmth. The familiar rhythm of sunrise and sunset has ended forever. Time continues. The orbit continues. Only the light has changed. For many years, astronomers wondered whether planets could actually survive these extraordinary transformations. Then, observations provided remarkable evidence. In recent decades, scientists have discovered planets orbiting white dwarfs. Some are likely survivors from the original planetary system. Others may have formed later from leftover material. One particularly fascinating system involves the white dwarf WD 1856 +534. A giant planet roughly the size of Jupiter circles astonishingly close to its tiny stellar remnant. How it arrived there remains one of astronomy's great puzzles. Perhaps gravitational interactions with neighboring planets gradually pushed it inward over billions of years. Perhaps the system experienced an entirely different evolutionary path. Whatever the explanation, one extraordinary fact remains. The planet survived the death of its sun. Sometimes the evidence appears in even stranger ways. Astronomers studying certain white dwarfs notice heavy elements such as calcium, magnesium, and iron in their atmospheres. Ordinarily, those elements should quickly sink beneath the surface due to the star's immense gravity. Yet, they remain visible. Why? The leading explanation is hauntingly beautiful. Ancient asteroids, destroyed planets, fragments of long-dead worlds. These objects drift too close to the white dwarf and are torn apart by its powerful gravity. The resulting debris slowly falls onto the stellar surface. In effect, the white dwarf quietly consumes the shattered remains of its former planetary family. The star has died. its planets continue returning home. Some planetary systems experience even stranger fates. Massive stars end their lives not as white dwarfs, but as neutron stars or black holes. For many years, astronomers assumed no planets could survive such violent endings. Then came one of the greatest surprises in modern astronomy. The very first confirmed exoplanets were discovered orbiting a pulsar, a rapidly spinning neutron star left behind after a supernova explosion. These worlds circle an object that emits powerful beams of radiation like a cosmic lighthouse. The environment is unimaginably hostile, yet planets exist there. Whether they survived the original explosion or formed afterward remains uncertain. Either possibility is astonishing. Even one of the universe's most violent events could not entirely erase the possibility of planetary systems. If intelligent life somehow existed on a world orbiting a white dwarf, their understanding of the universe might differ profoundly from ours. They would know no warm sunlight. Their oceans, if any remained, might exist only beneath thick layers of ice, warmed by internal heat. Their star would slowly fade over trillions of years. Every generation would inherit a slightly dimmer sky. Perhaps their oldest myths would tell stories of an age when the heavens were bright, when daylight filled the world, when the star was young. To them, those tales might sound like impossible legends, much as we imagine dragons or lost civilizations. Yet, the stories would be true. There is something quietly moving about these orphaned worlds. They remind us that relationships in the universe can outlast dramatic change. The light may vanish, the warmth may fade, but gravity remains remarkably loyal. It continues holding planets close to stars that no longer burn. Orbit after orbit, century after century, billion after billion, the dance continues even after the music has almost ended. Perhaps that is why these worlds feel strangely hopeful rather than sad. They teach us that endings are often transformations rather than disappearances. A living star becomes a white dwarf. A bright planetary system becomes a silent one. Yet motion continues, memory continues. The quiet companionship between star and planet survives long after the fire itself has faded. And somewhere tonight, beneath skies no human has ever seen, countless lonely worlds continue circling tiny stellar embers. No sunrise greets their mornings. No brilliant daylight warms their landscapes. Only the faint glow of a long-finished sun remains, still enough to guide their endless journey, still enough to remind the universe that even after the brightest lights go out, some stories continue, one silent orbit at a time. 11. The first objects the universe ever made. Everything has a beginning. Every mountain, every ocean, every tree, every star that has ever illuminated the night sky, even our own sun, so dependable that it feels eternal, once did not exist. There was a time before Earth, before the Milky Way, before planets drifted around distant stars, before the first atom of oxygen ever filled a living lung. If we could somehow travel far enough into the past, we would eventually reach a universe so young that nothing familiar remained. No galaxies decorated the darkness, no constellations stretched across the heavens, no black holes waited silently between the stars. Only an expanding sea of newly born matter, slowly cooling after the unimaginable beginning we call the Big Bang. And then, very gradually, the universe built its first creations, not planets, not solar systems, not even stars like our own. Its earliest structures were stranger, simpler, yet without them, nothing else would ever have existed. Even more astonishing, some astronomers believe a few of these ancient survivors may still exist today, quietly drifting through the modern universe like living fossils from the dawn of time. Tonight, we journey farther into the past than ever before to meet the universe's oldest children, the first objects it ever learned to create. The universe began in extraordinary simplicity. Immediately after the Big Bang, there were no complex elements, no carbon, no oxygen, no iron, no gold. Those ingredients belonged to a much later chapter. Instead, the young universe consisted almost entirely of hydrogen and helium, with tiny traces of lithium. That was all. No rocky planets could form, no oceans could exist, no life could emerge. The universe possessed the ingredients for light, but almost none of the ingredients for complexity. For hundreds of millions of years, darkness ruled. Astronomers sometimes call this period the cosmic dark ages. The name sounds mysterious, almost mythical, yet it describes a remarkably peaceful era. The universe had become transparent after the Big Bang's brilliant afterglow faded. Ancient light traveled freely through space, but there were still no stars to replace it. No galaxies glowed across the heavens. Imagine standing beneath a sky with no sunrise, no moon, no constellations, and no distant galaxies. Only endless darkness stretching forever. That was the universe's first night. Yet even in that darkness, gravity quietly continued its patient work. Tiny fluctuations in the density of matter, differences so small they were almost impossible to imagine, slowly began growing. Regions containing just slightly more hydrogen attracted a little more material over millions of years, then tens of millions, then hundreds of millions. Gravity gently gathered enormous clouds together. The universe had begun building, not through sudden miracles, but through quiet accumulation. Grain by grain, atom by atom, gravity became the first architect. Eventually, something extraordinary happened. One of those great clouds grew dense enough for its center to become incredibly hot. Pressure increased. Hydrogen atoms collided more frequently. Then, for the very first time in cosmic history, nuclear fusion ignited. The first star was born. Astronomers call these pioneers population 3 stars. The name sounds almost backwards. Shouldn't the first stars be population 1? In fact, astronomers developed the naming system before fully understanding stellar history. By the time the mistake became obvious, the terminology had already become standard. So the oldest stars received the highest number. Science occasionally carries little reminders that discovery is rarely perfectly organized. These first stars were unlike anything visible in today's night sky. Because the young universe contained almost no heavy elements, the gas clouds cooled less efficiently while collapsing. As a result, many population 3 stars grew extraordinarily massive. Some may have contained hundreds of times the mass of our sun. They burned with astonishing brilliance, blue, blinding, almost unimaginably hot. Yet earlier tonight, we learned one of the universe's great paradoxes. The brightest stars live the shortest lives. These enormous pioneers consumed their hydrogen at breathtaking speed. Many probably survived only a few million years. Compared with the age of the universe, they lived scarcely longer than fireworks exploding in the darkness. The first lights appeared, then quickly vanished. Yet their brief lives transformed everything. Inside their blazing cores, these stars forged the universe's first heavy elements: carbon, oxygen, magnesium, silicon, iron. When they eventually exploded as supernovae, those newly created atoms scattered across surrounding space. For the first time, the universe possessed the raw materials needed for rocky planets, future oceans, future mountains, future living creatures. Every atom of calcium in your bones, every iron atom in your blood, every oxygen atom you breathe, all owe their existence to generations of stars that began with these earliest pioneers. The first stars did not simply illuminate the universe, they taught it chemistry. For many years, astronomers assumed every population 3 star had disappeared long ago. Given their enormous masses, That conclusion seemed perfectly reasonable. None should still exist today. But the story may not be quite so simple. Recent computer simulations suggest that not every first-generation star necessarily became gigantic. Some may have formed with much smaller masses. Tiny stars burn far more slowly. As we discovered earlier while exploring the remarkable red dwarfs, the smallest stars can survive for trillions of years. If even a handful of low-mass population 3 stars formed shortly after the Big Bang, they could still exist. Right now, somewhere within the Milky Way or beyond, ancient survivors quietly shining after nearly 14 billion years. No confirmed example has yet been found, but astronomers continue searching. Imagine discovering a star that has witnessed almost the entire history of the universe. A star older than every galaxy collision our sun has ever experienced. Older than our solar system. Older than nearly everything we know. It would truly be a living fossil. Even if the very first stars themselves have vanished, some of their immediate descendants certainly remain. Astronomers have discovered extremely old stars containing astonishingly tiny amounts of heavy elements. One famous example is SMSSJ 031300.36-670839.3, whose atmosphere contains so few metals that it likely formed from material enriched by only one ancient supernova. Another remarkable object, sometimes nicknamed the Methuselah star, appears to be almost as old as the universe itself. These stellar elders preserve chemical fingerprints from the earliest chapters of cosmic history. Reading their atmospheres is a little like reading faded handwriting preserved inside an ancient manuscript. Every element tells a story. Every atom remembers. The universe's first structures were not only stars. Long before galaxies assumed their graceful spiral shapes, smaller collections of matter began gathering together. Tiny proto-galaxies slowly merged. Dark matter halos attracted ordinary gas. Countless little structures gradually combined into larger ones. The magnificent galaxies we admire today grew through an astonishingly long history of mergers and cooperation. The Milky Way itself is not a single original object. It is a family assembled over billions of years. Even today, it continues absorbing smaller neighboring galaxies. Creation, it seems, never truly stops. It simply changes scale. Perhaps the most ancient objects we can observe directly are not stars at all. They are globular clusters. These magnificent spherical swarms contain hundreds of thousands of stars packed tightly together. Many formed over 12 billion years ago, long before the sun, long before Earth. When we observe one through a telescope, we are seeing an entire community of ancient survivors still orbiting the Milky Way after nearly the whole lifetime of the universe. Walking beneath such a sky, if walking there were possible, would feel like entering an ancient city whose oldest citizens remember stories no one else can tell. It is remarkable how much of the universe still carries memories of its beginning. Earlier tonight, we explored cosmic ghosts lingering long after ancient stars disappeared. Now, we discover that some witnesses may never have left at all. Old stars, ancient clusters, primitive galaxies, each quietly preserving fragments of the earliest cosmic chapters. The universe is not only expanding through space, it is carrying its own childhood forward through time. Perhaps that is one of the most comforting ideas in astronomy. We often imagine the past as something permanently lost. Yet the cosmos rarely throws anything away completely. Instead, it preserves pieces of every age. Some become atoms, some become galaxies, some continue shining as quiet stellar elders. Like elderly storytellers sitting beside an ancient fire, they have watched almost everything unfold: the birth of galaxies, the formation of planets, the appearance of life, the rise of civilizations, all while patiently continuing their own gentle existence. And somewhere tonight, Hidden among the billions of younger stars filling the Milky Way, one ancient survivor may still be quietly glowing, a silent witness from the dawn of creation, still carrying the memory of a universe that had not yet learned how to make planets, oceans, or people. Still shining softly across nearly 14 billion years, waiting for someone to recognize one of the very first lights that ever existed. 12. The final dawn before eternal night. Every sunrise feels permanent. Tomorrow morning, somewhere on Earth, the horizon will slowly brighten. Darkness will retreat. Clouds will catch the first golden light. Birds will begin singing. Another ordinary day will quietly begin. It has happened for billions of years. It feels impossible to imagine a universe where no sunrise ever comes again. And yet, somewhere in the unimaginably distant future, there may be one final dawn, not only for one planet, not only for one civilization, but for the universe itself. A last star will rise above the horizon of its final surviving world. Its ancient light will gently illuminate the landscape one final time. Then, the star will fade, the sky will grow dark, and no new sunrise will ever follow. Tonight, we have traveled from the universe's very first stars to the oldest galaxies, the quietest oceans, the loneliest planets, and the last patiently burning red dwarfs. Now we arrive at the final chapter, the place where every story eventually leads, not with violence, not with fire, but with an almost unimaginable silence, the slow arrival of eternal night. It is easy to think of the universe as timeless. The stars above us seem eternal because human lives are so wonderfully brief. Entire civilizations rise and disappear, while the constellations barely seem to change. But earlier tonight, we discovered that every star carries an invisible clock. Massive blue giants burn rapidly. Stars like our sun shine for billions of years. Tiny red dwarfs may survive for trillions, no matter how patient they are. Everyone eventually reaches its end. The universe possesses no truly immortal stars, only remarkably long-lived ones. That simple truth shapes everything that follows. Because stars are more than beautiful lights in the sky, they are factories of warmth, makers of planets, creators of chemistry. Without stars, galaxies become quiet collections of cooling remnants drifting through darkness. For an unimaginably long time, the universe will remain filled with light. Even after our sun disappears, countless other stars will continue shining. Entire galaxies will still sparkle across the night. Red dwarfs, as we explored earlier, will patiently illuminate the cosmos long after brighter stars have vanished. If humanity, or some future civilization, survives for trillions of years, they may still live beneath gentle crimson skies lit by these tiny stellar embers. Compared with today's brilliant universe, it will already feel quieter. Yet daylight will still exist. Life may still find energy. Hope may still travel on beams of starlight. The age of stars will continue, just more softly than before. Eventually, however, even the remarkable red dwarfs begin reaching old age. One after another, they exhaust the hydrogen that has sustained them for trillions of years. Some quietly become blue dwarfs, a type of star that does not yet exist because the universe remains far too young. Then white dwarfs, then slowly cooling black dwarfs. The pace is astonishingly slow. A single human civilization could not witness even the smallest fraction of these changes. Entire histories become insignificant against such timescales. Yet, the universe never rushes. Its endings arrive with extraordinary patience, one quiet star at a time. Imagine standing on a distant planet during those final stellar ages. The night sky would no longer resemble the one we know. There would be no bright spiral arms crossing the heavens, no blue giants, few neighboring galaxies visible at all. Earlier tonight, we explored how cosmic expansion slowly carries galaxies beyond one another's horizons. By now, almost every galaxy outside the local gravitational neighborhood has disappeared forever. The observable universe has grown astonishingly lonely. Only a handful of ancient stellar remnants remain nearby. The sky has become quieter than any human has ever experienced. Then comes one unforgettable morning. Far above the frozen landscape, one tiny red dwarf rises above the horizon. Its light is dim, soft, deep crimson. It has already shone faithfully for perhaps 10 trillion years. Generations beyond counting have watched it climb into the sky. Its routine has become so familiar that no one imagines it could ever end. But this dawn is different. Deep within its tiny core, almost all of its usable hydrogen has finally been consumed. The star grows unstable. Its long story quietly approaches the final page. The light remains beautiful, gentle, almost comforting. No one looking upward would guess they were witnessing one of the last sunrises the universe will ever know. Eventually, without drama, without explosion, the light slowly weakens. The star transforms. Its warm crimson glow becomes something smaller, hotter, yet much fainter. A white dwarf remains where a living sun once burned. The final sunrise has passed. Darkness returns. This time, it stays. Does the universe truly become completely dark? Not immediately. White dwarfs continue glowing with stored heat. Neutron stars slowly radiate away their energy. Black holes themselves emit unimaginably faint Hawking radiation, at least according to our current understanding of quantum physics. Even these seemingly eternal objects are not entirely permanent. They lose energy extraordinarily slowly. For stellar mass black holes, the process would require around 10 to the power of 67 years. For the supermassive black holes lurking in galaxy centers, the waiting time extends to roughly 10 to the power of 100 years or more, numbers so vast they scarcely fit within ordinary imagination. Yet even these extraordinary giants eventually fade. The universe continues waiting, patiently, silently. This future is often called the Dark Era. It sounds frightening, yet perhaps the name is slightly misleading. Darkness is not nothingness. It is simply a different kind of existence. The universe does not disappear. Matter remains. Gravity remains. Space continues stretching. Ancient black dwarfs drift quietly through forgotten galaxies. Occasionally, two stellar remnants may pass close enough for gravity to briefly disturb the silence. Rare encounters continue happening, just incredibly slowly. Even eternity contains movement. There is another possibility that makes this ending strangely beautiful. Throughout tonight's journey, we have repeatedly discovered that the universe excels at surprising us. Hidden oceans existed beneath frozen ice. Lonely planets wandered without stars. Ancient photons continued traveling for billions of years. The oldest stars quietly outlived brighter companions. Again and again, reality proved more imaginative than expectation. So perhaps the far future still hides chapters we have not yet imagined. Modern physics offers several possibilities. Some theories suggest that protons, the particles making up ordinary matter, may eventually decay, although this has never been observed. Others predict that quantum events might occasionally produce extraordinary phenomena over unimaginable spans of time. Scientists continue exploring these questions, and many remain unanswered. The deepest future of the cosmos is still one of astronomy's greatest mysteries. The universe has not revealed every secret. Perhaps it never will. Yet there is something unexpectedly comforting about contemplating the final dawn. We often fear endings because they feel abrupt. The universe offers another perspective. Nothing here ends suddenly. Stars spend billions of years preparing for their final transformations. Galaxies age gracefully. Light continues traveling long after its source disappears. Even black holes require inconceivable stretches of time before fading. The cosmos approaches its future With extraordinary gentleness, it does not slam doors, it quietly closes them. Perhaps that is why the night sky has always inspired both wonder and peace. Every star above us represents a fleeting moment within an unimaginably long story. The sunlight warming your face tomorrow morning began its journey from the sun only 8 minutes earlier. Yet the atoms producing that light were forged billions of years ago inside the heart of a star. Everything connects. Every beginning carries traces of older endings. Every ending quietly prepares the way for something new. Even if one day the universe experiences its final sunrise, that moment will exist only because countless earlier dawns came before it. Every sunrise matters because it is temporary. Every star becomes precious because it will not shine forever. So tonight, as you look toward the sky, the universe feels a little different. The stars no longer seem merely distant points of light. They become companions on an immense journey through time. Some are young, some are ancient. Some have already disappeared, their light still traveling toward us. Others may continue shining long after every familiar constellation has faded. Together, they tell a story that began nearly 14 billion years ago and stretches farther into the future than imagination can comfortably follow. A story of creation, patience, change, and quiet endurance. Perhaps somewhere beyond the reach of every telescope humanity will ever build, the final sunrise is already waiting. Not tomorrow, not in a billion years, not in a trillion, but someday. Far beyond every calendar that will ever be written. Until then, the stars continue shining, the galaxies continue drifting, and tonight's sky remains one more beautiful chapter in a story that has not yet reached its final dawn. If these gentle explorations help you end your day with a little more wonder, consider subscribing, and I'll be here for our next quiet journey through the universe.